So this is an assignment related to topic moles and acids. We'll start with question 33. This question is about the preparation of aluminium, potassium aluminium sulfate, which is a double salt. The first step of the preparation, add an excess of aluminium foil to 10 cm cube, 2 mole per dm cube, potassium hydroxide. Write the balanced ionic equation. If you want to write an ionic equation, we cancel out the common ion in aqueous. And first, solid, liquid, and gas, we write them as it is. Like if a substance is a solid or a liquid or a gas, we don't change that. We write them as it is. And for aqueous, we just cancel out the common ion in the aqueous one. So this one is a solid, so we write 2Al. And water is a liquid, so we write 2H2O as it is. And hydrogen is a gas, so we write, now cancel the common ion in aqueous. So potassium is in aqueous, so potassium cancel out. So we're left with 2 hydroxide. And we are left with AlO2 and 2 of them, because it should be balanced as well, and the charge will be -1 because like K is +1 and AlO2, the charge will be -1. So this is an ionic equation. Calculate the number of moles of potassium hydroxide. So we have the concentration and the volume. So moles equal concentration into volume. Concentration is 2 and the volume is 10 divided by 1000. This will give us the moles, which is 0.002 moles. Hence, state the number of moles of aluminium that reacted. So the ratio is 2:2 or 1:1. So same number of moles will be there, because if we have the same ratio, then the same number of moles will react. If it was 1:2, then the double moles will be there, like twice the moles. Use your answer, calculate the mass of aluminium that reacted. Use a periodic table as a source. So we have the moles, we need the mass in gram. So we need the mass in gram, that is moles multiplied by the molar mass. In this case, the molar mass is atomic mass. So 0.002 multiplied by aluminium, which is 27 from the periodic table you have to use. So this will give us 0.54 grams of aluminium. Calculate the total mass of aluminium added to potassium hydroxide if 10% excess. So if 10% excess, like 0.54 gram was the mass of aluminium which is needed for reaction. So 10% excess means like 10% more. Or you can directly work out 10% excess means like you can take 110% of this. First, you can find 10% and then 0.54 plus 10%. That is one way of doing this question. And the second one, you can just take 110% of this. So how to take 110? 0.54 multiplied by 110 divided by 100. That will be 0.59 grams. The first two, identify the two hazards in the first step of the preparation. So what are the two hazards when we are preparing this? Like the first step of a preparation, add an excess of aluminum foil to a potassium hydroxide. So potassium hydroxide, alkali is there, so you can say it is corrosive. And then it forms sodium aluminate. And the second thing, hydrogen gas is there. So whenever a gas will release hydrogen gas, So it's a flammable, can catch fire. So one is related to the potassium hydroxide. Another one you can refers to the hydrogen. The second step of a reaction is addition slightly excess of 1 mole sulfuric acid. Calculate the volume of sulfuric acid. Calculate the volume of 1 mole of per dm which was reacted with potassium aluminate. So we have to use our answer like we already worked out the potassium moles of potassium aluminate. We work our previous answer will the ratio is 1:1. So same moles and just multiply by concentration. So we get the volume. And how would you show that the acid has been added in excess? So how will how we can identify